is tonight at 6 o'clock in the library. Must be a sophomore, junior, or senior. We have all grades above passing. Should be noted that freshmen are not eligible. You will be just participating all day in the other activities. Running out of time to vote for your teacher or pie in the face for your teacher. Looks like they're all fairly close. Donation support for Rachel Wood. That pie in the face will be on March 28th. The track meet that was originally scheduled for Saturday, due to the weather Saturday, has been moved to tomorrow, Friday, March 24th. All students, make sure you talk to your teachers and get your work made up. You will be missing school tomorrow. That means tomorrow instead of Saturday. Students, make sure you talk to all of your Maroon Day teachers today, even though it is a white day. So please stand for the pledge. Pledge allegiance to the flag
of the United States of America and to the republic for which it stands, one nation, under God, indivisible, liberty and justice for
You're definitely.
I like a lot of
You're
there's a button on your calculator. That's after the year.
I couldn't say if you just do extra.
No. Why is it there?
Power of Christ compels you. It means the same thing. The power of Christ compels you.
Why does my screen have the table and the graph in the same thing?
Probably because Owen had that yesterday. Care to share your magic with everyone?
Well, you can see the graph. Working.
I didn't even have a factor. Like, I don't.
Wizard tree.
I don't show kids because you would need to reset the calculator at the end of every single class to not confuse my algebra kids.
No, the goal is to.
But yes, this particular relic of technology has many, many wonderful mysteries in it. Finish the problem before you start playing with buttons. Just blew their minds.
No, I have 7. What are you? I have 07.
I take all this increased vocalization to mean that everyone is finished.
No.
And when you are finished with it, if you have not already, make sure you pick up packet number 3. Because we are just barely scraping off that last example and then starting 3-1. Gross. If you don't like the staples on them, y'all can blame Jace. Sanford. He stapled all of them.
This is actually absurd. I don't know.
It was on our FUBAR day.
Yesterday.
He got voluntold by the other kids.
No, your pens aren't even lined up.
What do you mean? Oh no, mine's perfect. Mine is
Because I need you to go a little more.
Oh. Sorry about that.
I'm also on.
Also, I think I've said it before, you will have your next quiz on Monday. And chapter 3 is short. If we stay on task, I expect the entire chapter to take us 6 days. Like, it is short. If you had Algebra 2 last semester, there might be some hiccups in that chapter because multiple snow days, including our Snowmageddon week off, means that some classes, including mine, did not get through as much or as much detail of logarithmic equations as we should have. So you got what you need for it. It's just some kids might say, oh yeah, we did this. Other kids might say, nah, I haven't seen this before. but it's not difficult stuff. If you had Algebra 2 last year, you're fine. So, there. Okay. If I'm going to test for an inequality, whether it is greater than or less than 0, I need to find the zeros because that's where we switch from negative to positive. In a rational function, I also need to find what? Well, the dots, spirit fingers. It's your vertical asymptotes. And to do that, I need to combine them to discover what my x-intercepts are and what my vertical asymptotes are. So, step 1, I need common denominators. So, this guy's missing a x plus 1. This guy's missing a x minus 4. Getting 3x squared plus 3x plus another x minus 4 over x squared minus 4x plus x is minus 3x minus 4. Okay, so I'm writing out the unfactored form, and because rational functions, the unfactored form tells us some stuff, the factored form tells us other stuff, so I'm writing both. Factors of my denominator, we already know, are x minus 4 and x plus 1. Numerator, factors of negative 12 add up to 4 by AC method. The numerator is factorable. So you can factor by AC method. You could solve by quadratic formula if you want to go deer hunting with a bazooka. Whatever you're going to do, you need to get back to these factors that 3x and x are the only way to make 3x squared. Factors of negative 4 that are going to get me that magic combination in the middle are plus 2, minus 2. Once I do all of that stuff, I have what I need for my cute little number line here. From negative infinity to infinity, this thing is going to have vertical asymptotes at negative 1 and 4. It's going to have x-intercepts at positive 2/3 and negative 2. Suppose I can move this guy over a little bit. Now it's just a matter of testing in those intervals. Now, you can test inside those intervals by just plugging numbers into a calculator. Heck, you could just look at your calculator screen and see where it's positive and negative. You could also know what the behavior of this graph is going to look like by putting your y-axis on there, knowing that your y-intercept is negative 1, knowing that if this is a vertical asymptote and this is a vertical asymptote and that's a y-intercept, horizontal asymptote is going to be at 3. So this thing's going to look something like meh. No, that one's going to be positive 1. I saw it, but you were saying it when I saw it. It's like
It's like the brown. No, I think it should be the
okay, but on technicality. I saw it as I heard the first yeah, and then it was too late. All right. All right. Whoop. There we go. So something like this.
How many brownie points do you like? How many brownies have you had brought in one class?
The record is 3 trays of brownies for the semester.
We were 12 last semester.
You got 2 and change.
Yeah, 2 last.
3 is the record, and it happened 7, 8 years ago. That class had a designated class attorney. So I do something like this. If I know the behavior of the graph, I don't need to do all the rest of the work. I don't need to look at my calculator screen. I know that it's going to be positive here, negative here, positive here, negative here, positive here. You could all just look at your screen. You could just plug in values. So I'm not going to say you have to have all of that business, because however you got there, really, now we're going to separate them. However you got there, you should have this somewhere. You should have that little number line, okay? So you got to have some work to show how you got to your form of that function. You also have to have your cute little number line, because I want to give you the partial points if you do the goof, okay? But then we actually need to answer the question, where is this greater than 0? Greater than 0 here, greater than 0 here, greater than 0 here. Everywhere it was positive, right? Positive is bigger than 0. Watch your signs, though. It says greater than 0, not greater than or equal to. So we're going to go negative infinity to negative 2, parenthesis. We're going to pick it back up at negative 1, go to 2/3. Union, pick it back up at 4, and head off to infinity and beyond. Okay. So I want to see, I'm going to say your x-intercepts, your vertical asymptotes, some sort of work to get to the function, to find them, because if you goof this up, these are going to domino. Your number line to show that you tested it, your final answer. Okay? And again, the how you test it could just be, I look at my screen and I see if it's above or below the x-axis. But you still have that number line to show I did something, I understand why this works. All right? So, I only had one person. Maybe everyone's just afraid to ask in case they get homework. But I was going to have an assignment of just like 2 problems with these, and that's it. But then the advisory day just kind of clustered everything. So, oops, I forgot. Yay for you. I do all the time. That's why I take medication. So, y'all got away with it. Hopefully you're still getting enough practice in class, though. But we were kind of in the middle of this. We were very, very close to done. Like an example and a half. I think we started setting this up, but we never actually solved. Right? Okay. So the short version is X kids are going to go to the rent the bus and go to Six Flags or whatever. So $600 split among X kids. That's your share of the bus, and then it was $60 ticket to get in minus it's 50 cents per kid. And we wanted to make sure that that total cost for a person. What? Well, I haven't written the thing yet. Just chill out. Don't be a quick draw. I haven't even said the word less. That's when we trigger the, oh no, we got to go the other way. Get it now before chapter 4. All right. Brand spanking new stuff. You're going to do everything in terms of graphs, fractions, and pi.
Ooh, I hate pi.
22/7.
That's an approximation. No, actually, no. You can always drop the class. You just get a withdraw fail on the transcript. You can drop a class at any time.
You don't want to. What does that do to your GPA?
It withdraw fail. It's a fail for the class. F 0. So I think you all had done, instead of let's get common denominators, everyone was cool with let's just multiply by x. Okay. So if I multiply the whole thing by x, we ended up with a quadratic, correct? So we would have had whole thing by x, I'll get 600 plus 60x minus 0.5x squared is less than 40x. Maybe you don't like 0.5. Maybe you don't like fractions. Could you have multiplied the whole thing by 2x? You're going to get the same zeros. You're going to get the same solution. So whatever your jam is, I'm going to move everything over to the right so I have a positive x coefficient. We're going to have 0.5 x squared, 40x's minus 60x's minus 20x's minus 600. And because it's on this side of the zero now, or the inequality, I will make sure to write that as greater than 0. And we were, oh yeah, that's right. We were really, really close. I think I still have this in the calculator, don't we?
Now that we had the minus 6, minus 5.
If you have it that way, then you're just going to want to see where it's less than 0. And it's going to be the exact same answer. You're going to have the exact same thing. It's just you're going to see where it's less than 0. Okay. So negative 40 to, what was my window? 0 to 120, negative 60, 75. Okay. So if I calculate a 0, left boundary was somewhere between there and, come on, Blinky, you can do it. There.
That's what I got last time. Is that right? Right. That's not
Hold on.
Yeah.
Well, 60 to 5, 60 less, an extra 50 cents. And it's the right and solve an inequality and determine how many students must go on the trip for the total cost to be less than 60, less than $40. 60, 10.
Huh? I'm not done. That is not what you should have gotten.
No.
That's what I'm saying.
No, because 60 don't make sense.
That'd be minus 60. Minus.
Oh, yeah, 60 makes sense because half of 60 is 30. 60 minus 30, 30, 10. Okay, so you have to have more than 60 kids on the bus. Yeah, that's right. Because remember, this is depending which direction you had your inequality, either less than or greater than. 60 is when it equals 0. So when we have 60 kids on the bus, that means it's going to cost each kid exactly $40 to go on this trip. They want it to cost less than $40. 61 or more kids.
I don't got no interceptions.
There's something wrong, Holly.
Yeah, your sign's wrong there. You need a negative in front of that.
What? Where?
Yeah, you missed your negative in front of it. I just put it there.
Oh. Thanks.
Just missed a negative. That's it. Okay.
So we can't use the negative next year.
So the idea is, can you set up the equation? I know you can solve an equation. I know you can calculator mojo. Can you set it up? Well, too bad. You're going to try. 61 or more, because I can't have 60 kids, because that's exactly $40. I want it to cost less than $40. 60 kids in a 7th grader? Okay. Like, we jokingly call all the freshmen in game club fresh meat. So when the 8th graders came up to our last geekathon, where someone was calling them, like, I don't know, less than fresh meat. What did they call them? It was like freezer meat or something. Like they're not even fresh. They're still in the freezer truck or something. I don't know. Like less than fresh meat.
Living meat.
There's
two
at
numbers in
least,
this one.
if it's
Wasn't it light?
When in doubt, draw it out. Has a perimeter of 250 feet. Length plus width is 250. Area, length times width, has to be at least 100. You have too many variables. You're going to need to rearrange your perimeter formula so that length or width equals stuff. You've got too many variables. We went through this before when we did like the candle and someone decided they were going to have a flamethrower size candle. Remember where we plug one formula into another? It's very similar to that.
I could do it.
Sorry. Those are notes for my speech. Just wait. How do you calculate the number? I'm actually asking.
Sine plus sine plus sine plus sine.
Or 2L plus 2W.
Is that the equation I'm supposed to use? Probably. This is probably fully round.
Absolutely.
Go all the way to the end. Because soon as these it all works. Because you look at it, you do the math, like, oh, this doesn't work. Two length plus two is perfect.
I've done good. I know that.
What am I doing tomorrow? I'm not
You're
good.
not eating donuts.
Bye, Bill.
3-2.
Okay. I'm good.
Hopefully 3-2.
Let's not ever do that again. It's very simple. Don't ever say that.
Are you gonna come?
See, many problems. Is it even better with the voice? Slowly depleting.
My connection today so okay, I'm just like on a different level. Like everyone's here and I'm like up here somehow. Like my brain is literally on a different wavelength right now.
Negative x squared, so
Yeah, I'm just
minus 125 plus 1,000 minus 1,000 5 125 halves.
so not negative, this I can punch the copper and I so when I heliocentric
Los premios.
Greater than or equal to. Must be at least this tall to ride. You start with your two basic formulas. Learn them back in middle school, maybe elementary. Perimeter is this, area is that. It says the area has to be at least 1,000. So length times width has to be greater than or equal to 1,000. I got too many variables there to jam into a calculator. Or to just solve. Maybe it is, I can solve it by just factoring or basic algebra. So the fact that they gave me the perimeter has to be 250 feet allows me to rearrange the perimeter formula to isolate one of the variables. If I isolate a variable, I can replace a variable by substitution. This is a very, very common application of geometry and algebra together. It will literally look the exact same except W's. I'm solving for length, you'll solve for width. Because it turns out a rectangle can be looked at from either direction. It's literally not. All squares are rectangles, not all rectangles are squares.
Yes, I know.
All right. So I'm going to end up with a quadratic again. Negative L squared plus 125L. Seems like we seem to be taking lots of those in here. You got a quadratic, get everyone to one side of the bus solved.
Now we solve for L.
Uh-huh. And just to make it entertaining, I'm going to solve by complete square. Plus 125, 125, so 5, and 1 to 3, 5, 625, 3125, 15, 625. Over 2, so that's negative 2,000. So that's going to be L.
No, he switched the sign.
I divided everything by A. I'm doing complete square. So 5, negative 2,000, so that's 13,625 over 2. Square roots. L is 125 over 2 plus or minus 13,625 over 2. So I'm going to multiply that by 2 because simplified radicals over 2. 27, 250, 10, 27, 25, 25, 25, so that's 4 by 27, 54, 108, 109, question mark, 5. I got 125 over 2 plus or minus 5 root of 218, 2180 over 5. No, over 2. Get some nasty decimal, right? You're going to get two different ranges because this is a negative parabola. It asks for a range of values. You're going to get one here, and it's the first one is like almost 10, and the second one I forget what. Y'all dump it in your calculator. Calculate zeros. Go to Y is. Claire. I'm going to put in x squared minus 125x minus 1,000. No, plus 1,000. My window should be reasonable for the problem. It says I have a total perimeter of 250. So the absolute maximum that my length could be is just a hair under 125. Because it'd be like 125 feet, 125 feet and a quarter inch on each side. So I'm betting a 0 to 120 window is going to be fine. My Y's, well, we're talking about our area. Our area needs to be at least 1,000. So I should probably go up to 2,000. I like 2,000. That works. Graph it and see what happens. Huh. Come on, Frank. Huh. Oh, barely. Got there. The rest of the parabola is somewhere down here. Okay. It asks for a range of values. Do I see a range of values that L could be? Here to here. Okay, so I would calculate A0 somewhere back here. It appears to be between 1 and 20. Frank, keep up. Calculate a 0 between 1 and 20. There. There we go. Close to 10.
So then how do you write this? This is greater than 0.
The range of values that is going to get me an area greater than 1,000 is going to be from about 8.59 to, go find the other one. I did a negative. I put a positive coefficient in the front. All it did was flip my parabola.
So I have mine like this.
Yes.
Okay.
It's going to have the exact same zeros. That appears to be somewhere between 100 and 120. I'll go 119, so I'm sure it's on my graph. Poke. 116 and change. We are absolutely getting that for an assignment. Yeah, we need those. Yeah, we do.
I don't like those.
You've been seeing them since Algebra 1. Plug linear substitution into quadratic multiplication. Like, rearrange perimeter, shove it into area. Rearrange surface area, shove it into volume. Go maximize or go find zeros. That's a very common application. We got to be able to do it. Okay. I can't keep going back and doing algebra 1 and 2. We're going to go on to 3-1. Womp. Y'all remember your exponent rules? Before we even do this, God, we better know our exponent rules. All right. First up, if I have 3x to the 4th plus x minus 2. Let's get some vocabulary in there. What is this called? Constant. What is this called? Variable. A constant is called a constant because its value is constant. It can never change. -2 is just -2. However, x could be anything. It could even be a yacht. So it's going to be variable. Now, specifically in this context, yes, x is a variable, but since it has this guy attached to it, what else is it called? This is the exponent. So what is the thing that the exponent is attached to called? All about that. Base. And whenever I have a number jammed up on variables, coefficient. All right, so we got to make sure we got basic vocabulary out of the way. Then our exponent rules. Starting with the easiest one that ever exists. If I have x to the 0, what does it equal? Uno. If I have x to the a times x to the b, what do I do? A plus B. If I have x to the A to the B power, I multiply. If I have x to the A over x to the B, subtract them. If I have, color. If we do x to the A over x to the B and it's all to the C, it's in parentheses. What's that C touching? It goes to all of them. And whenever I have an exponent to an exponent, I multiply them. So we get the full gamut of x to the AC, x to the BC. That also works if they're multiplied together in parentheses. If you ever have an exponent on a parenthesis, think of it like someone is on the hood of the car. It affects everyone in the car. You should probably deal with it before you go trying to move the car. Okay?
Just drive really fast. You just drive really fast and then hit the brakes.
That's how you kill someone. Don't do that. And finally, if I have x to the negative A, what is a negative? If I have a negative exponent, it just means reciprocal. Also, if I have a negative exponent and it's already on a denominator, a reciprocal, it turns into, the way that I tell my basic algebra classes is, you're too negative, go downstairs. It's kind of like when you come home and you're just in a really bad mood, so your parents tell you to go to your room. Well, once you're in your room, you're away from everyone who's making you in a bad mood, so you're happy now, okay? If I'm up here and I'm negative, I go downstairs to my room, well, now I'm happy, I'm positive. If I'm negative downstairs because your brother is pestering you, well, go upstairs, now you're positive, okay? So, these are the rules of exponents. This is Algebra 1. Well, actually, most of this is 8th grade math now. Or no, it's always been 8th grade math. It's just we're finally supposed to be putting the bar back where it's supposed to be. Well, 8th grade math, pre-algebra, whatever they call it. So, exponential form is anything that is of the form coefficient times base to the x. Not to be confused with power. Exponential form, my variable is in the exponent. A power form is a times x to the b, or x to the n, I should say. Okay? Remember when we did power regression? This is exponential regression, or exponential models versus power models. In a power model, your variable is the base. In an exponential model, your variable is the exponent. Okay? So, we should know all the stuff about exponents, including rational exponents. Remember reviewing those in the beginning? Okay, 4 to the second is 4 squared, 4 times 4, 16. If I say 4 to the 1/3, remember denominator is index, numerator is exponent. Okay, so it's a third root of 4. If I have a negative exponent, throws it downstairs, don't you dare go to decimal town with those, just write the fraction. Okay, if I ever see 5 to the negative 4th, what is it? Which is? Stop it! That's to the third. 625, cheater. You are absolutely a cheater because you have those exponent. About to get Rachel fired off again. So, yes, put it down on the denominator and write the actual value. Don't go to decimal town. All right. So, remember when we got in chapter 2, I said we know how to do all that analysis stuff so we can analyze any type of function now? Do you remember what these look like? Yes. Okay. We used to call them creeper functions because it creeps along, it creeps along, it creeps along, whoop, it takes off when you see it. Okay. Yes, there's a story about the kid who was stalking Miss McCurry, right? So, you can also just do these by knowing your powers in your head. Anything to the 0 power is 1. 3 to the first is 3. 3 to the second is 9. 3 to the negative first is 1/3. 3 to the negative second, 1/9. And then, yep, the 127th, 181st, 243rd, 729th. It's just going to keep getting smaller and smaller and smaller and smaller. So it creeps along, and then you spot it, and it takes off. I said it creeps along. What is it creeping along? The x-axis, y equals 0, which is a asymptote. It's a horizontal asymptote. Okay. Can you tell me all of the stuff? Domain. Domain, who's allowed to this party? Range. Mm-hmm. So 0 to infinity, parentheses or brackets. Because we never actually hit 0, right? I can't keep dividing by 3 and dividing by 3 and dividing by 3 and dividing by 3 and it's somehow now 0. It's going to be infinitesimally, just tiny. But it's never 0. Okay, what else do we got? X-intercept, Y-intercept, continuity, symmetry, what else? Increase, decrease, and end behavior. Okay, X-intercept, we said, nah. Y-intercept, in this case, uno. Continuity. It is continuous. Where? So I will say either continuous at negative infinity to infinity, or I can say continuous for all real numbers. I'll take it. Symmetry. Is it symmetric to the x-axis, the y-axis, or the origin? No. Intervals of increase and decrease. As I go left to right across the graph, where is it going, up or down? Always increasing. Limits. As I head all the way to the left end of the behavior, which is negative infinity, where's my y going? 0. It's going to curl along that asymptote forever. And then if I go all the way to the right hand, to infinity and beyond, and these get very big very fast, because exponential, like if you've used the word exponential or exponentially as a descriptor. My problems in life will increase exponentially the older I get. I want you to, oh yeah.
Okay, so you're telling me my grandparents don't have to work and they get coffee like 3 times a day, have problems?
Oh no, their generation, it was a logistic graph. Your generation, it will get worse. Okay? Specifically because of their generation. But that's indoctrination. I'm not allowed to say that. Let's keep going here. Thanks, South Dakota. All right. Now, before I go doing anything with this, remember that transformations still exist.
Oh gosh. So dumb.
See, Connor, that's why you don't call me baby.
What did you do? Come on, guys.
So, there is transformations that can happen to these graphs. What spot is that negative in? We have to call it C because B represents base this time. So, do you remember what the coefficient grouped in with X does? Remember, like this one is vertical stretch and compression, vertical reflection. So this one is horizontal. It's grouped in with the X. So I could just think in my head, this is all the powers of 2 flipped horizontally. And that's going to be the shortest way to do it. If you need to, if I say 2 to the negative X, could I rewrite like this? Because then I think anything to the 0 power is 1. Now when I plug in a 1, it's 1 over 2 to the first, a half. When I plug in a 2, it's 1 over 2 squared, 1/4, 1/8, 1/16, 1/32, 1/64, 1/28. So what's going to happen when I go the other way? When I plug a negative number in, well, if I say 2 to the negative 1, 2, 4, 8, 16, and so on. So this would be like that creeper finding his hiding spot in the bushes outside your living room. He's going to come flying in and then settle in for the night. Okay? Now, all of the stuff we just said on the other side, what's the domain of this? Range. X-intercept. Y-intercept. What is the only thing, look at that list of stuff for part A. What is the only thing that's going to change, well, 2 things, that are going to change from here to here? Okay. So what we're going to do is all that stuff, I'm going to say ditto, except increase is now no, decrease is now yes. What else changes? My end behavior is going to swap. So the limit of, no, it's g of x. The limit of g of x as x approaches negative infinity is now positive infinity. The limit of g of x as x approaches positive infinity is now 0. So nearly the same thing. Do you understand that all this stuff is going to, as I translate it up and down and left and right, as I change the base, it's going to just monkey with this stuff a little bit? Okay. So if we understand that, we can shorthand these first couple of examples. What? You need to say it louder than that. I live in a state of perpetual sensory overload. Properties of exponential. Oh, yeah, there we go. Look at the very next slide. There There it is. Okay. So the only thing that's going to change is dependent on whether it's exponential growth or decay. Growth means the base is greater than 1. Decay means the base is less than 1. I want someone to tell me why this says 0 to 1. Why do both of these represent B can't be negative? I want you to think about when you what happens when you repeatedly multiply together negative numbers. Negative, positive, negative, positive, negative, positive, negative, positive. Well, what happens when it's a rational exponent instead of an integer? I would like you to take, like I can do 3 to the 6.25 power. I can do that. I would like you to take negative 3 to the 6.25 power. And how is that different from 3 to the negative 6.24? Like just pick two exponents that are really close to each other. Do like to the negative 6.25 to the negative 6.24. How does that change it? Okay. So what you're going to have is, if you dare to use a negative exponent, what you're going to see is you're going to see something like this, where they're going to alternate between integers like the step function. Which is why the definition of these say where b is greater than 0. Okay? That's why it says b greater than 0. Because as soon as I have a base as a negative, then it's going to take this nice continuous creeper function and it's going to split it into positive and negative chunks, every other integer. And that gets wild. Okay? So we're just going to say our base is always 0 or greater. Or sorry, greater than 0. It wouldn't be 0 because what's 0 to x? 0. All right, what's 0 to the 39th? Probably the easiest function you'll ever graph, but okay. So, example 2, every one of these are talking about transformations. We have beat to death transformations yet again in this class. In addition to algebra 2, I would like to say graph and tell me transformations for this guy and this guy. Go. Oh wait, we just did that. This guy. Okay. Yep. And remember, every time you change the base, it's a new parent function. So like 2 to the x is its own function family from 3 to the x. Just like x squared is different from x cubed. Okay. Those two tell me what transformations, both of them have 2 transformations, and then graph it. Okay, the transformation spots and what they do has not changed. Okay. Looks like we're there. First one, what two transformations happen? Vertical reflection or reflection in the x-axis, and horizontal translation left 2, because it's grouped with x, it's still backwards land. Okay, so this tells me I vertically reflect. This tells me I'm going to go left 2. So a normal 4 to the x parent function has a horizontal asymptote. A normal 4 to the x says I will start at 0, 1, because anything to 0 power is 1. If I translate this left 2, then I will just take that point and move it left 2. But then I say I'm going to vertically reflect it. So instead of my creeper function going up, it's going to go down. And then I can keep using the powers of 4. I don't have to use my calculator for this. I just know that away from this, I'll treat this like 4 to the 0, 4 to the first, 4 to the second, 4 to the negative first. I'm still going to have those same values. It's just they're moving in a different direction. So here's 1/4, 1/16. Here's 4. 16's already down there. Like that. But make sure you use your big kid words in there. Say that it's a vertical reflection or reflection in the x-axis and a horizontal translation left 2. Okay? Contestant 2 likewise starts at a 4 to the x, but what does that 2 do? Okay, vertical stretch, or if we understand that stretches and compressions are the same family, I can also call it a. We really hammered on stretch and compression. Starts with a D. Dilations. Okay. I can just call it a vertical dilation if you don't want to say stretch or compression. We hammered on stretch and compression in Algebra 2, so you understood what the values did. But you could just say vertical dilation by 2. And what does that horizontal reflection, or I could say reflection in y-axis. So normally I would have my horizontal asymptote at 0, Normally, I would start with my point at 0, 1, but a stretch by 2 means, whoop, if it was 1, now it's 2. A horizontal reflection means it's going to have this curve with powers of 4. I just have to remember I'm doubling all of them. So if I would have gone right 1 and up a quarter, I will now go up a half. If I would have gone right 1 and up a 16th, I'll now go up an eighth. If I would have gone left 1 and up 4, I'll now go left 1 and up 8, because it's got that vertical stretch. What you're going to notice is that the vertical stretch and compression, those dilations, they don't do a whole lot to an exponential graph because exponents are so powerful. The idea of repeatedly multiplying together something is just has a larger effect on it than multiplying it by 2 a single time. Okay? If I say times 4 times 4 times 4 times 4 versus times 2, like which one just sounds more powerful? Any of you played one of those lame like crowd fighting games where you have to make your crowd go through the gate that says times 5 or says plus 8? It adds a bunch of guys to the mob and then they just keep shooting each other. Oh, I keep seeing ads for it all the time. Kind of like that. That's just weeding out people who don't understand basic math and like watching flashy things go on screen. Okay? We understand that exponent make good, make big. Okay? Multiplication is not nearly as powerful as exponents. So don't worry about any of the other ones. I think we understand translations and all that kind of stuff. Okay. This is where we might be getting into hairy territory because some of us don't have as much experience with E. Okay, everyone was introduced to E. Okay, so E is a special irrational number just like pi. It has an infinite string of non-repeating digits after it, just like pi. And it is the natural limit to a natural or continuous growing exponential function. And the idea is if something grows based on itself. So like if I said starting in 6th grade, you will have to read 100 words every day. And then every day after that, I'm going to add half of what I added the day before. So on day 1, you have to read a 100-word thing. Or maybe it's a 100-page, I don't know. Like a 100-page thing. The next day, I'm going to add half of that. The next day, I'm going to add half of what I added the day before. The next day, I'm going to add half of what I added before. So what's that, 12.5, so 187.5. The next day, I'm going to add half of what I added the day before. What's going to happen when I keep doing this? Eventually, it's going to peter out, and I'm going to add practically nothing. That's what E is. E is as I continuously grow or continuously add things based on a self-referential factor, there is a natural limit to it. And that limit is about 2.72. In the same way that circumference divided by diameter is about 3.14. Okay? It is a very, very special number. It should be used a lot in chemistry because reactions happen continuously. Things that happen continuously are going to use base E. In this case, it's just another number that is my base of my graph, right? If I say e to the 4x, well, y'all know where e is on your calculator? Just like you know where pi is. So if I jam a 1 in there, what do I get? E to the 4th. I don't know what e to the 4th about 2.72 is to the 4th power. So I'm going to grab my calculator. E to the 4th? Oh, I didn't hear the 50 in front of it. Okay. So that's way off grid. What about if I jam a negative 1 in there? Yeah. Ooh. So maybe I just need to make my graph really huge. I'm going to make this go by hundreds. Okay, so you said 54 something for that guy? What if about if I, oh no, that was e to the 1st. Sorry. Okay, what about if I put in 2? Now I'm at e to the 8th. Is big. So I'm already off the grid. I went by hundreds. I'm already off the map. Okay, it's an exponential graph. It's just got a new base. Instead of plugging in a 3 to the x, I'm going to plug in a e to the x. I can graph it by table. Okay? We just got to know what e is because it's going to take effect in some of the equations we're going to deal with. So, I would like you to just nicely graph the b's. Let's do these two because they don't toss anything up into that exponent. That other one took off pretty fast. Now it does ask you to describe the transformations again. Transformations are the same regardless of the base. You have vertical dilations and reflections, horizontal dilations and reflections, vertical and horizontal translations.
You just kind of missed that. No, it's not. I feel like if you go she's used to it, she used to all get or something. Not just show that to her. She just sees that.
That's the parent function. That's the parent function. I'm going to do it by transformations.
What would you call the 4 right there? If I was in, like, say, a transformation.
Oh,
What would
that
be?
4 on part A, it's in the, well, we can't call it B spot anymore, C spot. Remember that the horizontal compressions and stretches always happen by bass-ackwards land. They're always going to happen by the reciprocal. It would be a horizontal compression by 1/4.
But if it's just a negative, then it's a horizontal reflection.
Correct. Remember, it has the opposite effect. Think about when you mess directly with your input. If X is the money that you are making and then I throw a 4 in front of it, does the goal you're saving towards get closer or further?
Wait, horizontal compression by 1/4?
Yes.
What if it was -4? Then it'd be a horizontal.
Negative,
4.
a negative 4 in front of it?
Yeah, if it had e to the -4x.
Then I would have a horizontal reflection and a horizontal compression by 1/4. I'd have both. And it looks like most of us are finishing up the second graph. Talking about transformations. Up here by part B, I have the parent graph. I don't know all of my powers of E. But I did at least memorize that E squared is about 7.29. And it was easier for me to remember that because that's also 9 to the 4th. So it was a number that I kind of remembered anyway. So I'm able to put e to the 0, e to the first, e to the second on my graph. This is my parent function. And then I'll go do some transformations to it. What does this do? Okay, so when I do that, I'll take my entire asymptote and move it. You really want to mess with kids as a coach, you tell them to move their asymptote. They just, like, they falter in their tracks and what? I'm still going to say above this, anything to the 0 power is 1. But now, this does a horizontal reflection. So I'm just going to take those values of e to the x and flip them. So e to the first is about 2.72. So I'm going to make a dot about 2.72 above my asymptote. E to the second is about 7.29. So I'm going to go back here to the second and go up 1, 2, 3, 4, 5, 6, 7.29. E to the negative first is 1 over e, which is tiny fraction. I've got enough to make this graph by transformation. Okay? So what I'm saying is if you just know 1 or 2 powers of a thing, you don't have to always run to the calculator. You can just do it by transformation. What I want you to be very careful about is I will see kids just look at their calculator. They'll see a point here, they'll see a point here, they'll see a point here, and do this. You will get points off on your test, okay? You better know where that asymptote is and not cross the line. Okay? Oh, this one was a horizontal reflection, or you could call it reflection in the y-axis. This one was a vertical translation up 3. Yep. Well, you have to say how many units. Like if I said, I want you to move to the next seat. That usually means the one right next to you. What if I said, I want you to move to that seat? And just kind of like nodded in that direction. Which one? Right? If I say a translation, I got to say how many units. Because I don't know how far we're supposed to move up or down. Same thing for, well, no, get back here. Stop it! Frank. All right. So if the parent function, e to the x, looks kind of like this, here's about 2.72, here's about 7.29. What's the only thing I do to it? I move this entire graph down 1, 2, 3, 4, 5. There you go. Okay. Vertical translation down 5. Over 2 up e squared, which is about 7.29. Okay, so mostly we're going to do these just by dumping in your calculator, graph by table. But we got to know where stuff is. Okay. Yes, because the other class is like half a problem behind you.
I'm gonna call Anna to what you guys